So here's the second part of the notes. It's assuming that you know what's written in the first part, so if you don't know, watch that video. But that video talked about how to change from an improper fraction to a mixed number and from a mixed number to an improper fraction. And we're going to do the second part here, which is addition. How do you add mixed numbers, which would be a number and a fraction, so like 2 3/4 or something. So I'm going to start out by kind of writing the general rule. The general rule, maybe I'll put it in red for dramatic emphasis, is that you add the integer, the number in front, and the fraction parts separately. So add integer and the fraction parts separately. And I'm not going to write it down, but I should at least comment that if your fraction part, if you end up with an improper or a top-heavy fraction, it's sometimes called, then you do need to change that into a mixed number and combine it with the one before. You'll see that soon. So my first one I want to write is 3 4/7 plus 6 2/7. So for the first one, we already have the common denominators. We'll work on getting common denominators soon. But want to first point out that 3 4/7 is really like saying you have 3 and or 3 plus 4/7. And 6 2/7 is really the same as 6 plus 2/7. You can kind of break up your fractions that way. So now what I'm really doing then, just combining the 3 and the 6. So 3 plus 6 gives us 9. And then we do the fraction part separately. So we have these two here, and maybe I should actually write it out for the first time around. But I end up with a 3 plus 6, and I have a 4/7 plus 2/7. And if you wanted to, you could look at it as though there's a addition sign right there as well. But we end up with 9 here. Adding fractions, you have to have common denominators, which we do. So you just add the numerators, which gives us a 6, and keep the denominator the same. So that theirs would be the final answer for this first example. We don't have an improper fraction, and we're done. My next example, I'll try to make it a little bit more dicey. Try coming up with several examples that are going to cover a lot of the different challenges you might see. This one here is going to be 4 3/8 plus 2 7/8. And again, if you wanted to, it might be helpful to kind of look at these as though each fraction is really, each mixed number is a number plus a fraction. And we can take these parts separately again. So I have my 4 plus my 2 over on one side. Then I have my 3/8 plus my 7/8 over here. And 4 plus 2 gives me a 6. But now here in my 3 plus 7, I can add those because I have common denominators. But I get a 10 over 8. Now this here, in the earlier section we looked at how to take care of that, but if you have a 10 over 8, that's improper. So what you could do is you could say, well, I could take 8 of these 10 away, and that's going to give me a 1. So maybe I should look at it as though it's 6 plus this. So I'd have 6 plus. That 1 in front now takes away 8 of my 10, so I have 2 of those 10 still left. So I end up with 7 2/8, which we're almost done. If you're going to really do the fractions well, you should always reduce. 2 and 8 are both even, so then you could reduce that to 1/4. So the final answer would be 7 1/4. Maybe we'll do another example right here kind of next to it. So my next example is going to be 3 1/4 plus 8 1/2. I'll maybe throw some pluses in here just for dramatic emphasis. And now when we take and add the integers, we have 3 plus 8, maybe I'll write it out. So 3 plus 8 plus 1/4 plus 1/2. So the new thing here is we don't have common denominators anymore. But the 3 plus 8 would give me 11. Then over here I need to get common denominators. So my common denominator will be a 4. And in order to come up with that, I have to take my second fraction, multiply the denominator by 2. Well, if I'm going to multiply the denominator by something, I need to multiply the numerator by something. Like we've looked at already in this chapter, 2 over 2 is really just 1. So I'm multiplying 1/2 by 1, which doesn't change its value any, but gives me 1 times 2 is 2 over 2 times 2 is 4. Now when I combine these parts, I have 1 plus 2 is a 3. Then I have my common denominator of a 4. So last but not least, I can just kind of put it all back together again. So final answer would be 11 3/4, and 3/4 is already reduced. One more example, and then I'm done with adding fractions, adding mixed numbers portion. So my last one is going to be 8 7/8 plus 13 1/2. And for here, I'm going to combine my integers. So I have 8 plus 13. Then combine the fractions, which would be my 7/8 plus my 1/2. And from there, I might as well add these. So 8 plus 13 gives me a 21. And now if I want to get common denominators, it's going to be an 8. I didn't do an example where you had to multiply both fractions by something to get a common denominator. You can pick that up in earlier sections of notes. But here I need to multiply the 2 by 4 to get the 8. Then I need to multiply the 1 by 4 also, so I'm multiplying by 1 essentially, which gives me now 7/8 plus 4/8. And you could view it as though there's a plus in there. So I have 21 plus 11 over 8, which 11 over 8 is an improper fraction. So I could take 8 of those 11 away and change that into a 1. So this 1 here is really kind of like 8 over 8, which once I take 8 of the 11 away, I'm left with 3 over 8. So final step would be to combine my 21 plus 1. So I have 22 3/8 for a final answer. The next video talks about how to do the subtraction.